All right, problem number 1. A chef is preparing spaghetti and meatballs. He's made 2 dozen meatballs that are each 2 inches in diameter, and he has some sauce in a pot that is 12 inches in diameter and filled to within 2 inches of the top. How many meatballs can the chef add to the sauce before the sauce overflows the top of the pot? All right, well, let's take a look. We're dealing with volume here, right? So we have a certain volume of sauce in the pot, and each time we add a meatball, we increase the volume of stuff in the pot by the volume of the meatball, right? And I think we're assuming too that there's enough sauce to cover all the meatballs too. I mean, if you had, a shallow pan with just a tiny bit of sauce in the bottom, and you tried to add 2 dozen meatballs, they may not, um, all just sink down into the sauce because a meatball might look like that, and you add a whole bunch of them, they're going to pile up, around the sauce, and so we're going to assume though that the we have enough sauce in the pan to be able to cover all the meatballs. Okay. So every time we add a meatball, the volume of stuff increases in the pot. Okay, and we're going to assume that the meatball just drops down and the sauce covers it completely. All right. So let's look at the volume of a meatball. All right. Meatball. Okay, the meatball is basically a sphere, right? So that's a sphere with a kind of a equator there, and it's got, it's got a radius here, and the volume of a sphere is equal to 4/3 pi r cubed. All right, that's just a formula you'll have to remember. And we're told that the diameter of a meatball is 2 inches. But we need the radius in the formula. We need the radius, right? So the radius is just 1 inch, right? All right. So if we plug 1 inch in for the radius, so 1 cubed is just 1, so the volume of 1 meatball is just 4/3 pi. Okay. So every time we drop a meatball in, we increase the volume of stuff in the pot by 4/3 pi. So let's take a look at this pot. All right. So we have this pot. I'll draw it. It's fairly deep. It's a chef. So he's cooking for a lot of people. And he's got this pot. I'll draw a handle here. And we're going to assume this pot is basically a cylinder. Alright. I suppose I should have drawn this a little more cylindrical on the bottom. Okay, so it's basically a cylinder. And it's filled within 2 inches of the top here. Alright. So the space up here is 2 inches. Alright, this space at the top is 2 inches. And let's see, we're told that the diameter of the pot is 12 inches. So that means the radius is 6 inches. Alright. So, what we really are concerned with here is the volume of empty space. We really don't know what the volume of sauce is. And we don't really care too much as long as we've got plenty of sauce to cover all the meatballs. Okay, so what we want to know is how many meatballs can we add until all this empty space is filled, and then you add one more meatball and it's going to flow over the top, right? It's going to spill and make a mess. We don't want to do that. Okay, so this portion, this volume here of empty space is what we're concerned about. So the volume of a cylinder is the area of the base, which is pi r squared, times the height, right? Because it's basically a prism, only with a round with a round bottom. Okay, so the volume of a cylinder is pi r squared h, and in this case the radius is 6, so we have pi times 6 squared, which is 36, and the height of empty space is 2. Okay, so that's what we're interested in. I'm going to actually write that down here. Empty space. Okay, that's the volume of empty space. Okay, so the number of meatballs that we can add will be based on the volume of each meatball, or how many of these 4/3 pi volumes can we add to this 72 pi volume until it's filled. All right, so let's do that. Let's I'm going to scroll down just a hair. So let's let n be the number of meatballs. All right, and so then the n times 4/3 pi, okay, that would give us the total volume of meatballs. And when that is equal to the empty space in the pot, then the pot is full, right? So when that's equal to 72 pi. Alright, so now we just need to solve for n. And you can see if we divide both sides by pi over pi is just 1. Okay, so pi goes away. So we end up getting n is equal to 72 times 4/3. Oops, not 4/3, sorry. 3/4. Right, because we want to multiply by the reciprocal. 3/4. Okay, so if you divide 72 by 4, half of it is 36, half again is 18. So we get 18 times 3, and that's just 30 plus 24, which is 54. So n is 54. So we could add 54 meatballs to the sauce before it overflows. Okay? Now, the only problem is, I think when I wrote this problem, I meant to use some other number other than 2. Okay? I said there's only 2 dozen meatballs. So technically, we only have 24 meatballs. Alright? Now, if I had said, 6 dozen meatballs, then we could add 54 of them. But which I think is what I had meant to do, and I just didn't proofread my problem very well. So, but it's a good lesson in reading carefully for me as well as you, because I imagine some of you may have solved it and then gotten 54 meatballs and thought, okay, that's done. But we only have 2 dozen meatballs, I guess, and whether I meant to put that or not, we really only have 2 dozen meatballs to work with. So technically, we can only add 24 meatballs because that's all we have. Balls meat, what? I'm like thinking backwards here. Whoa, okay, I don't know where that came from. Alright, I meant to write, I'm losing it today. Okay, meatballs, okay? So technically we only have 24 meatballs, so that's technically the answer. Although if you got 54 meatballs, you're doing pretty well. It's kind of a mean trick to say it's 24 meatballs because we only had 24 meatballs. So, but either way, whichever answer you got, you did well. Okay, if you got either one of these. So, there you go.